Dear students, in previous class we were discussing about the continuity of composition of two functions. When f and g are two continuous functions, then their composition, g composition f is also continuous. Composition of two continuous functions is also continuous. Now consider, and also we know that the rational function is also continuous. Rational function is continuous, or polynomial, all polynomial functions are continuous, and the composition of two continuous functions are continuous, and so on. Now check the continuity of a function. F of x equals x square plus x plus 1 divided by x plus 2. Is it continuous? Where x differs from 1, so minus 2. Clearly this function is continuous. Why? Because its numerator, so this is nothing but this of the form some p of x by q of x, where q of x is this numerator and the q of x is the denominator. We know that both this p of x and q of x are polynomial functions, and they are continuous. And also when p of x and q of x are continuous, p of x by q of x is also continuous. So in the light of that argument, we can conclude that this f of x equals x square plus x plus 1 by x plus 2 is also a continuous function. Agreed. Now again, consider another one. Suppose f of x equals, consider the function f of x equals x square root of x plus root x. Check whether the continuity of that function. F of x equals square root of x plus root x. Check whether it is continuous. So here, how to find out the continuity, or how to discuss the continuity of this function? So for that, first we consider let g of x. G of x equals root x. Consider g of x equals root x, and h of x equals x plus root x. Consider these two functions. G of x equals root x and h of x equals x plus root x. Clearly these two are polynomial functions. They are also continuous. Agreed. Now what about their composition? That is g composition h. What is g composition h of x? G composition h of x equals g of h of x. That equals g of, what is h of x? X plus root x. But the g image of x is root x. So what about the g image of x plus root x? This is something like square root of x plus root x. So clearly g and h are continuous functions, and we know that the composition of two continuous functions is also continuous. Hence but g composition h is x plus square root of x plus root x. Hence this x plus root x, square root of x plus root x is also continuous. Agreed. So this continuity is discussed by, or this proved by using the idea that the composition of two continuous functions is also continuous. Agreed. Now consider another one. Suppose consider f of x equals square root of 1 plus mod sin x all divided by x. Check the continuity of the function f of x equals square root of 1 plus mod sin x all divided by x. How to discuss the continuity? Here again, we define number of functions. Suppose f1x. Let f1 of x equals root x. Okay, f1 of x equals root x. f2 of x. f2 of x equals 1 plus mod x. f3 of x. f3 of x equals sin x. f1 of x is root x. f2 of x equals 1 plus mod x, and f3 of x equals sin x. So consider the composition. f1 composition, f2 composition, f3 of x. So it is F1 composition F2 of F3 of x. What is F3 of x? It is sin x. This is nothing but F1 of F2 of sin x. What is F2 of x? 1 plus mod x. So what is F2 of sin x? 1 plus mod sin x. But what is F1 of x? Square root of the image of the element. Square root of the element. So here F1 of 1 plus mod sin x equals square root of 1 plus mod sin x. So finally, this numerator is nothing but the composition of these three functions. F1 composition, F2 composition, F3. Where F1, F2, F3, we know that sine function is continuous. Root x and 1 plus mod x are also continuous functions. Then composition of these continuous functions are also continuous. So clearly, this f of x equals, here what is f of x? Hence f of x equals f1 composition, f2 composition, f3 of x divided by some f for x, where choose this f4 of x equals x. Okay, then check this composition. Suppose it is h of x. So clearly this f of x is nothing but h of x by f4 of x. Agree? So we know that h of x, this composition are continuous. Moreover, f of x equals x is also continuous, and the rational function is also continuous. So finally f of x is continuous. So this is the idea to prove the continuity of these types of functions. So we use the ideas that polynomial functions are continuous, a rational function is also continuous, and the composition of continuous functions are also continuous. Agree? Okay. Now, suppose fnx equals f of x all power n. Is it continuous? F is a continuous function. Suppose a is a part of R. And so another example, that a is a part of R. Define f from a to R. Suppose f from a to R is continuous. F from a to R is continuous on a. What is a? A is a part of R. Means f is continuous at each and every point on a. And it is defined as fn of x equals f of x all power n. Can you say that this fnx continues here? Sure. Why? This is because of, by induction, when n equals 1, what happens? When n equals 1, we know that f of x equals f of x. That means f is continuous. So when n equals 1, f of x is continuous, means result is true. Okay. Now assume the result is true for n equals k. That is, fk of x equals f of x all power k, comma, which is continuous. Now, let n equals k plus 1. When n equals k plus 1, what is fk plus 1 of x? Fk plus 1 of x equals fk of x into f of x. Clearly we know that f of x is a continuous function. Why? Because that is our hypothesis. Fkx is continuous according to our assumption. So, and we know that the product of two continuous functions are continuous. When f and g are continuous, f of x into g of x is also continuous. So the product is continuous. Hence, fk plus 1x is continuous. So it means the result is true for n equals k plus 1. So as by induction hypothesis, the result is true for all n. Hence, fnx equals f of x all power n is continuous when f is a continuous function. Agree? Okay. Now we are going to an interesting problem. That is, check whether the continuity of f of x equals, next example, f of x equals x minus greatest integer x on R, where x is on R. On R. Check the continuity of the function f of x equals x minus greatest integer x on R. So here, what is greatest integer x? Greatest integer x means It is the integer less than or equals x. Integer less than or equals x means greatest integer 2 equals 2. Greatest integer 3 equals 3. Greatest integer 4.5 equals 4. Less than or equals that integer. Greatest integer 5.2 equals 5 and so on. So this is the greatest integer. So here we define the function f of x equals x minus greatest integer x. And so, how to prove the continuity of this function, or how to check the continuity of this function? First, there are two cases. Let x is an integer. Suppose x is an integer. X is an integer means that x equals k. K is an integer. Okay. So what about f of x? F of x equals k minus greatest integer k. Okay. Now, so what about limit x tends to k minus of f of x equals limit x tends to k minus greatest integer k equals, it is k minus, what is greatest integer k when x tends to k minus? That is the condition. When x tends to k minus, x tends to k minus means x strictly less than k. Okay, so it is k minus of, when, since x tends to k minus, the respective integer part is k minus 1. So it is k minus of k minus 1. K minus of k minus 1 equals 1 itself. Agreed. Now again, what is limit x tends to k plus of f of x? Limit x tends to k plus of f of x is limit x tends to k plus of k minus greatest integer k. So k plus means it has a tendency to reach k but slightly greater than k. So it is the respective integer is k itself. So it is k minus k equals 0. Means f of k minus differs from f of k plus, means the function is discontinuous. Means it has a removable discontinuity. That is, it has a discontinuity of first kind. Means x minus greatest integer x is discontinuous when when x is an integer. So when x is an integer, f of k minus differs from f of k plus, means it has a discontinuity of first kind, means the given function x minus greatest integer x is discontinuous when x equals k. X equals k where k is an integer. Now the second case, suppose x is outside of this integer, x is outside of such, means this x presents in r minus h or complement of z in r. Complement of z in r. So x fall in r minus z means then there exists some integer m such that m less than r less than m plus 1. Between any two integers there exists a non-integer function, non-integer value. Suppose it is a rational number, irrational, whatever may be. So m less than r less than m plus 1. Where m is an integer, m plus 1 is also an integer. Okay, m is an integer, m plus 1 is also an integer. Since x is in complement of z in r, x is not an integer. So you can find out an r between two integers m and m plus 1. Agreed. Now, what is limit x tends to? Limit x tends to r minus of f of x. Limit x tends to r minus of f of x is nothing but limit x tends to r minus x minus greatest integer x, r minus x minus greatest integer x. So that equals limit x tends to r minus x minus greatest integer x means, come on, it is x minus, what is x? Then it is r minus, what is greatest integer x? Here it is m. Why? Because x tends to r minus r minus of that one. So m less than r, so its respective value is m itself. Okay. So when limit extends to r minus x, f of x is r minus m. Similarly, find the limit extends to r plus of f of x. Limit extends to r plus of f of x is limit extends to r plus of x minus greatest integer x. It is r minus, then greatest integer of x, r less than m plus 1, r plus means, so it is again m itself. Why? Because greatest integer r plus means it has a tendency to reach r, but it is slightly greater than r and is also less than the nearest integer m plus 1. So it is nothing but r minus m. Clearly, this f of r minus equals f of r plus equals f of r equals r minus m. Hence, the function is continuous at when x fall in r minus h. So this is the given function. F of x equals x minus greatest integer x. So we discussed the continuity of the function when x is a real number. So here we found that when x is an integer, the function is discontinuous. But when x is not an integer, the function is continuous. Agreed.